Now you don't need to worry about your studies, schedules and homework and the stress for competing for IIT JEE and other engineering exams. This is one place to de-stress and learn all the intricacies, tips and tricks of physics, chemistry and maths, and succeed in your exams the easy way. All around us we see different things like water, food, rocks and sand, stars and galaxies, animals and plants, and even the air we breathe. They occupy some volume around us and are made of different particles we collectively call matter. The science of studying the different physical phenomena exhibited by these matter is called physics. Matter we see around us is made up of particles like sand is made of small particles. A rock can be broken down into smaller and smaller particles. A spoonful of salt and sugar can be mixed into a glass of water, after which the whole water tastes salty or sweet, which shows that the particles of sugar and salt has spread across water. The size of the particles can be very, very small, so small that we cannot even see through our naked eyes. In a glass beaker full of water, if we add even a pinch of potassium permanganate, the whole water turns pink. The particles are so small that we can color the water with even a pinch of the compound. The particles are not continuous, but there is space between them. When we mix large amount of sugar in the glass of water, then all the sugar particles get placed in between water particles, and there is no change in the volume of water. The particles are continuously moving. For example, when we light an incense stick in one corner of the room, the fragrance spread to another part of the room, which cannot be possible if they are not moving. The particles attract each other. For example, we cannot break a stone unless we use a hammer to break the forces between particles. All the matter we see around us can be categorized under three broad heads called states of matter. Solids are those matter which has rigid shapes which does not change easily unless we apply force to it, for example iron rod, stone, sugar, salt, pen, etc. They have definite shape, distinct boundaries. Ice has distinct shape and hence is considered as solids. Rubber has a distinct shape, it can be stretched and it regains shape when the force is removed, is also considered as solid. In solids the particles are very closely held together. Liquids on the other hand are matter which does not have rigid shape, and they take the shape of the container they are kept in, but they have a definite volume. For example water, oil, milk, juice, etc. In liquids particles are loosely held together and the space between them is more compared to solids. Gases, unlike solids and liquids, neither have rigid shape and nor definite volume. For example, air around us is composed of several gases: the cooking gas LPG or liquefied petroleum gas, compressed natural gas or CNG, and even water vapor. In gases the particles are very, very loosely held and the space between them is large compared to liquids and solids. Now we will try to understand if the state of matter changes, and if so under what circumstances. We take the example of water, which we all know can exist both in the solid form as ice and gaseous form as vapor. We take a glass beaker and pour some ice in it and start heating the beaker from underneath the ice and measure the temperature. We will find the temperature of the ice does not change till all the ice melts into water and remains at 0 degrees Celsius. If we continue heating, the temperature of water will continue to increase till 100 degrees Celsius, when the water will start to boil and change into water vapor. This shows that temperature plays a significant role in the changing the state of the matter. The energy required to change 1 kilogram of ice at 0 degrees Celsius, also called the melting point of ice, at 1 atmospheric pressure into 1 kilogram of water, at same temperature and pressure, is called latent heat of fusion for ice. All this energy is used up just in changing the state of ice. The particles absorbs just enough energy to break the attractive forces between each other in ice and become much more free-flowing as in water. Similarly, when the water changes into vapor at 100 degrees Celsius, also called the boiling point of water, the energy required is called latent heat of vaporization. Some substances like camphor and ammonium chloride changes its state directly from solid into vapor, and this is called sublimation. There is another physical phenomenon which is responsible for change in state of the matter, and that is the application of pressure. For example, when we open a soda or cold drink bottle, the carbon dioxide gas dissolved in the drink changes its state into gas as we release the pressure and comes out with a fizz. When we compress a gas, the particles come closer and closer, ultimately changing its state into either liquid or solid. Carbon dioxide gas, when compressed, changes to solid carbon dioxide, also called dry ice, which is commercially available. Thus we see that change in temperature and pressure changes the state of the matter. However, when there is no change in temperature or pressure, the matter can change its state. For example, when we leave our clothes after washing to dry, the water in the clothes slowly changes its state into vapor and leaves our clothes dry even if there is no change in the temperature or pressure. This phenomenon is called evaporation. This happens along the surface exposed to the atmosphere. The particles at the surface gain sufficient energy and breaks from the rest of the matter into atmosphere, thereby changing its state. Evaporation and boiling both result in changing of the state from liquid into gaseous form. However, the difference between them is that evaporation happens only at the surface, whereas boiling happens in the whole of matter. Evaporation can happen in a wide range of temperature, but boiling only happens at a particular temperature called boiling point. Rate of evaporation depends on the temperature of the atmosphere. If the temperature increases, the rate of evaporation increases. It also depends on humidity of the atmosphere. Higher the humidity, lesser is the evaporation. The wind velocity in the atmosphere also increases evaporation. Evaporation causes cooling. For example, when we sweat, the temperature of our body decreases. This happens because water in the sweat takes energy from our body when it evaporates. Another example is when we put acetone or nail polish remover on our palm, then we can feel the cooling sensation in the palm as the acetone evaporates.